right, 12.10, solve problems involving numerical data. So this is less about making a line graph and more interpreting it and using it to help us solve problems. So hopefully by the end you'll feel comfortable saying I can solve problems using data in a line graph. So we'll get to filling in the blank on your notes. First, we are going to go over this problem. Deshaun measures the height of the stem of the bean plant he is growing. He displayed the data in a line graph. So we can see the line graph here. We have the day. We have the height. Now, it doesn't tell us what the height is in. We can assume probably inches. Like feet would be weird that we'd have like a 7-foot tall bean plant, especially that fast. So if it's day by day, much more reasonable that it is inches. But could be centimeters probably as well. What is a reasonable estimate of the stem height on day 14? So notice day 14 is over here, but if we go up, there is no data point. So we could just estimate to say, based on the pattern that it's been showing, what would be a reasonable estimate? So, like I said, what do we notice? Well, it's increasing. It's getting bigger. Hopefully we notice that as the days go on, the height gets taller. On day 2 or on day 1, it was like half an inch. Whoops. Sorry. There we go. On day 3, it was 1 inch. On day 5, it was 2.5 inches. On day 8, it was 4 inches, 10, 5 inches, 12, 7.5. So notice it's not a nice linear graph. It's generally increasing, but there's not a clear, like every day it grew a certain amount. It changed a little bit. Now, what happens to the stem from day 10 to 12? Well, if we look, here's day 10, here's day 12. We go from 5 inches to 7.5 inches. We'll assume it's inches. So it increased by 2.5 inches. And again, we can look at the graph, look at the numbers, draw some conclusions. Okay, it is inches. So it grew 2.5 inches. So what might be a reasonable estimate on day 14? Well, we could apply the same amount of growth, right? If it grew from 2.5, I just want to move so you can see the days. From 10 to 12, it grew 2.5. That was 2 days, remember? So then 12 to 14, maybe it'll grow another 2.5. If I took 7.5 plus 2, that would be 9.5, right? Plus another half, we'd get 10 inches. Or if we looked on our graph, we could say, okay, up another 1, 2, plus another half, we would be at 10.5. We can sort of see if the line kept going, that's where it would end up. I think graphs are fun to read, and I feel like y'all have a pretty good sense of graphs, so we're just developing it even further. Sorry if you can hear my dog and her chew toy. So this is where I want you to write on your notes. You can use numerical data represented on a graph to help you solve a problem. So it's just a clearer way to picture it instead of just having the different data points written down. Make sure you have that in your notes. If you need to write anything, that's why there's the blank space. But there shouldn't be as much to calculate with this. It's more looking at a graph and interpreting that graph. So this line graph shows the number of milk cartons delivered to the kindergarten classes at school over 10 days. What do the data values on day 10 or day 5 and day 10 indicate? I want you to read the different choices and pick which one feels the best. I'm going to go ahead and zoom out so you can see the question and the whole graph at the same time. So what do the data values indicate? All right, hopefully you said something or chose the one about how they're the smallest, right? That's when the least number of cartons were delivered. There's a lot of other inferences we could make, but fewer milk cartons were delivered is just clearly the case. Maybe kids were absent. Who knows why, but that is what we can see. All right, now we'll take a look at some others. Just 4 questions. This video should be a little shorter, which is always nice. All right, the line graph shows the number of smartphone users from 2010 to 2018 in the U.S. So we can see our years on the x-axis, users in millions on the y-axis. So how does the number of smartphone users in the U.S. change from 2010 to 2018? Pick the best answer. All right, hopefully you picked that it increased. They increased, right? By almost 200 million, because it starts down here at just about 50, maybe a little bit over, maybe like 60, 62, ends at 250, so that's almost 200 million more that it increased by. All right, so these will all be about the same line graph. So this time, between which years does the number of smartphone users in the U.S. change the most? All right, hope you got it. It's where the line is the steepest. That shows the most change, right? Which looks like here to here. And then we can even do some calculating to double check. So again, if we're going from 60 to 125, well, that's 65 different. From 125 to about 175, that's 50 different. From 175 to maybe 210, that would be what, 35? Yep. Somewhere in there. Hopefully my mental math's right. And then from like 210 or maybe 205 to 250 is maybe what, 45 or 40? So this one is the most amount of change. Again, we can see that it's the steepest. That also shows the most change. 2 ways to think about it. Same graph. What was the approximate number of smartphone users in the U.S. in 2010? All right, we just went over that. It's somewhere like 60, 62, halfway in between 50 and 75. So we have to estimate our best within there. And last question. What is a reasonable estimate of the number of smartphone users in the U.S. in 2022? All right, hope you got it. Definitely has to be bigger than 250, right? There's no reason to think that it would go back down. So then if we say, okay, we know that's 4 years after 2018, right? 2018 to 2022 is 4 years. So let's look 4 years before that. It had been at about 175. So from 175 to 250, it went up 75. So we can assume, you know what, it probably go up about 75 more to 325, right? Plus 50 is 300. Another 25 is 325. So somewhere in that range, because it looked like it was pretty consistently getting bigger. And we can infer from there. If you have any questions, let me know. Good luck.